Hello student. Today we are going to second lectures on X-ray spectra. This chapter name is X-ray spectra in atomic physics and molecules. Question is that mostly law. How to ask in a examination state and explain the mostly law. In 1913, Mostley's formed a symmetric study of K radiations of some elements is there: calcium 20, silicon, titanium 22, V 33, no, 23, Ca 24, magnesium 25, ferrous 26, copper, nickel 28, copper 29, zinc 30. Announced law for law known as the Mostley law. This law can be studied as the frequency of each corresponding X-ray line is approximately proportional to the square of the atomic number of the target element. There is a target element shown in this figure. So this figure is showing that there is some element: zinc, copper, nickel, copper, ferrous, manganese, calcium, like this, and there is a K beta. This is a beta, not B, beta 1000. The radiation is going to increase just like this. So the plot of K cells observed and measured by mostly is shown in a figure. So this is a V is equal to KR in a bracket Z minus sigma bracket close into square. For each element investigated the K radiation consists of two strong spectrum lines. Positions of line shows that there is a steady decreases in spectrum separation. काय काय म्हणायचे तिथं positions of the line shows that there is a steady decreases in a separations of wavelength. Steady decreases in separation and wavelength as the atomic number is increasing. Okay, so most mostly work was continues by the other investigation. Their work has shown that in however element each of the K alpha into phi into K beta lines is itself a closed doublet. They are the closed doublet. Which one? K alpha phi K beta lines is itself a closed doublet. These four lines are designed as K alpha 2, K beta 2. Okay. X-ray uh, spectrography of all innumerable elements shows that mostly is a valid for all the elements in the periodic table. हे सगळं तुम्हाला periodic table मध्ये मिळतील. For from the study of such graph, mostly नाही. From the study of such graph, uh, mass एक मिनिट पुस्तकात show that mostly where is this? Where is this? From study of the such graph, mostly right, from the study of such graph mostly gives the expressions for frequency of radiations in above numbers or 6 like this. V vector is equal to kr into bracket sig z minus sigma bracket square into same centimeter inverse 1. This is equation number 1. R is a Rydberg constants and this value is a 10,907 737 centimeter semi inverse 1. For sigma and k are constant. For k alpha lines, आता हे काय for k alpha lines साठी काय आहे sigma is equal to 1, k is equal to 3 upon 4. With the Bolmar's formula in V is equal to R into bracket Z minus 1 square, then this equation we can write into in a bracket 1 upon n square minus 1 upon n square like this 2n square n 2 square. Bohr's theory mostly work. So V is equal to R into bracket Z minus 1 square. You can write 1 upon 1 square and minus 1 upon 2 square. Means n square like this centimeter. Okay. This equation number become 3. For L alpha line is equal to sigma is equal to 7.4 and k is equal to 5 upon 36. Hence the mostly with Balmer formula you can write V is equal to R in a bracket Z minus 7.4 bracket square in a bracket 1 upon 2 square minus 1 upon 3 square centimeter raised to minus 1. And this is a figure. Y-axis in the root of V upon R 0 to 10, 20, 30, 40, 50 like 90 and y-axis is going to Z 0, 10, 20 like this and then radiation is increases like this. So in this case first K alpha 1 downside K alpha 2 and now upper side K beta 1 and then upper K beta 2. This is a figure for important. This is a mostly long. So again this in this case explain an energy level diagram of cadmium indicating the line structures of X-ray energy level. Okay. cadmiumचे structure आणि X-ray level सांगायचे आपल्याला. The change in atomic configurations rise in KLM म्हणजे ते cell KLM cell etc and series of X-rays spectral lines is shown by the energy level diagram. When high speed electron is incident, an atom has sufficient energy or sufficient energy to remove electron from inner cell, and this vacancy is filled by one electron from neighboring outer cell. The 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 given rise to radiations of the energy h mu and that and h mu is given by energy difference between two stationary states. That is, suppose one electron is missing from K cell, and that is the atom is in energy state Ek. If an electron jump from L and K shell, the atom will be in E2 shell. The frequency of spectral line radiations radiated when electron goes from L and K cell or when an energy state of atom is charged from Ek to El is denoted by alpha gamma k is equal to ek minus el divided by h. This is equation number 1. Another electron from a cell steal for there may jump to L cell gives the radiations of another frequency. This process will be in calcium cadmium arsen. In case process will case then positively positively charged on capture on electrons, then positive charge काय करता है इलेक्ट्रॉन करता है. Okay, consider example of cadmium is Z is equal to 48. The electronic configurations of cadmium is given by cadmium is a 48. Then electronic configuration like this: 1s square in K cell, 2s square, 2p6 is a L cell. म्हणजे बघा 1 असेल तर के सेल, 2 असेल तर एल सेल, 3 असतील ते एम सेल, 4 असेल ते एन सेल, 5च्या पुढे असेल ते 5 असेल तर ओ सेल. Like this configurations. So X-ray radiation K, L, M, and O represent N is equal to 1, 2, 3, 4 respectively. Thus, in cadmium, two electrons in K cell are most lightly bonded to atoms, and second binding energy goes to uh, 2 2s electrons, then sigma into 2p electrons in L cell. After L electron, the order order of bonding is 3s and 3p. So 3d 4s and 4p 5s electron respectively is shown in a figure as shown as so far, which is L is equal to 0 and J is equal to 0. The the remove of electron is which the remove of electrons is respectively respected by the S1s inverse minus 1 without one electrons removing in the subcell. The energy state is represented by 2s into the half. Similarly, the remove by 2s electron is shown in 2p inverse 1 from cell leaves on incomplete cells 2p raised to 5, which is give rise the 2p half and 2p 3 by 2, which is corresponding to absorption limit of L first and L third respectively. Among these conditions is going to similar in position like this. Again, removal of 2s, 2, 3, and 3s, 3p, and 3d atoms give the rise to 2s half, 2p half, and 2d 3 upon 2 like this. The term is the 5. So in this case, thus the electrons of rules from alpha spectrum is similar to the optional spectra, optional 3p. Okay, thus delta n is equal to arbitrary uh, assume arbitrary assume delta L is equal to plus or minus 1, delta J is equal to plus or minus 1. And let's see the following diagram. And this diagram is showing this dotted line is a LMN like this KLMN show in a figure in a book. So you have seen this graph. And then today we are stop here to second lecture. Tomorrow we are going to third lecture on the same chapter.